the textbook spends many pages worth of agony going over the overloaded function examples, I thought perhaps we could look at just a couple of them, and that might help you get the idea of them in general. So I have the Feetinches header class here, and I thought maybe I would look at the greater than operator. I'm in the header class now. It expects to, remember you can write it this way as well, with or without the space. And it's going to expect to receive into it a Feetinches object by reference. It would be good to run over to the program, then to the main, and see how that's implemented. Should be here somewhere, or I have a different version of it from doing the other program. Just a second, let me stick some code in there. Hold on. Just for purposes of argument, this is not actually in there, but we can say if, oops, I even misspelled it. If we'll do a comparison, and we'll say if 1 is less than 2, which has us compare two objects. You know that typically you could compare two numbers if numeral 1 is less than numeral 2, but these are objects, so how do you compare those? And the purpose of overloading, I got to do the right operator, right? The purpose of overloading the less than operator is so that you can compare two objects differently. And let's go see how the code would work for that. It's in the CPP file. And you will be returning a bool. You see how I wrote an if statement so that my answer comes back as a bool. It's a Feetinches class. It's an operator for less than, and it expects to receive a Feetinches object that we'll call by reference, that we'll call right. Well, the way this works is that if you think about it, this 1 is less than 2, that all gets transferred as one unit, if you will. That's the command. And then 2 becomes the parameter of the argument of the function. And so that's why you say operator less than expects to receive the information on the right, because it already got the left object, it already got as part of the less than. We'll establish a bool that we'll call status. That's just to set the variable. And then we'll say if the feet of this object, so this object would, in the example in the end, if you go look at the 14-9 at the end of the chapter, they actually used this pointer to the current object, but in this case we're just identifying the specific private variable of the object on the left. So if you can say like left dot feet, but we don't put that in because it doesn't need a name. If feet is less than right dot feet, status is true. Else, and we're not doing, we have to do, these are feet and inches objects. So if the feet is less than, then we're done. We don't have to do more. Then we have to do the next calculation. If feet is the same as right dot feet, okay. So we're starting off to say the feet are the same, and the inches is less than right dot inches. So the feet is the same, but the inches are less. Then we also have a true. Otherwise we have a false, which would mean that either the feet or the inches are greater than. So you can return the status. Just to look at the equals then, since we're doing feet and inches, we could say if feet is the same as right dot feet and inches is the same as right dot inches, return true, otherwise return false. So those operators tend to be written that way, and then it just depends on what you're doing. This is the overloaded friend C in and C out. Let me run back over here and find them. For some reason the C in and C out are friends, and that's because they're actually members of the IOStream class. That's why we always include that. That's why they're friends. And this is part of chapter 12. So this is the output stream object and input stream object that we will return uh, to the main program. By reference, it's a by reference operator. That's different from these. You notice none of those have the ampersand. Just you have to memorize it. And then here's less than and greater than. And here we're going to get this is for cout. We're going to get an output stream object by reference that's going to enable us to do the cout, and we're not going to change this. A Feetinches object by reference, that's the information that it's giving us, and then we'll calculate how to print it out when we get over there. I'll show you the definition in a second. Whereas the input stream, you know, when you're getting something in from the user, you're going to be changing it, right? So you wouldn't put const on that object because you are going to be changing it. And we'll go find, let me go find the, here we go. We put the friend designation in the header class, but we don't have to put it here. And this is a return type, let me do the cout. Where's the cout? Here. Of return type output stream by reference. And they just use stream and object as the names, whatever. So we'll say into the stream to be output. Well, that's the equivalent of cout. Now, if you didn't do chapter 12 yet while we're doing this, which is the way I taught it this particular semester when I'm making this video, this would be new information to you. But if you just think about cout, replace that stream with cout. Into the stream, put object.feet, and then put a space feet comma, and then into the stream, put object.inches, and the word inches, and then return the stream. So just this stream, you replace the word cout in your mind, and then it will work. And for the cin, goes the same thing, opposite direction. Prompt the user for the feet, so ask them how many feet, and then replace cin right here. For stream, cin. So into the stream, put object and put whatever comes in the stream, put it in object.feet, and then prompt for the inches, and then do this simplify. What this simplify function does actually is take 12 feet, 5 feet. My principal in elementary school was 6'6", so he told everyone he was 5 feet 18 inches tall, which, you know, worked when we were in 4th grade, but doesn't work now. So the simplify function will actually say if the number of inches is greater than 12, then subtract 12 and leave the number of inches and increase the number of feet by 1. That simplified functions, I don't know, it's up here somewhere, I guess. But I think there it is. If Feetinches is greater than or equal to 12, then, because even if it's 12 inches, you still have to add a foot. So then add 2 feet, the inches divided by 12, so that would give you 1 foot and 6 inches. So add feet by 1, and then add to inches the modulus of inches divided by 12, the remainder. So it would be 1 feet 6 inches. So you leave a 6 down here in feet, in inches, and put add 1 to 12. And if inches is less than 0, so that if they're 6 feet minus 4 inches, then, you know, somebody might be smart aleck and write that. I'm sure none of you would try to break the program by doing something like that. Anyway, so you subtract from, oh, I can't put that on this stream. Maybe I'll make another video with it. It's too long. We're already at 10 minutes. I have to stop. Maybe I'll make another video with that.